Hi everyone. Today I am going to discuss the topic about multi-threading models. In multi-threading models, the topic comes under the overview and process management. That topic comes from the operating systems. So let's recalls the session before we enter to the multi-threading models and issues. Threads runs inside the process and multi-threading improves performance and OS manages thread execution. These are all the things which we have discussed in the previous session. So the topics for discussion on the today's session is multi-threading models, user kernel thread mapping, threading issues, design challenges. And explore the concepts, different ways to manage threads and mapping affects concurrency. Each model has trade-offs. These are all the things which we are going to explore the thing. And why we are using multi-threading models means define how threads are managed, affects performance and scalability, and important for OS design. Multi-threading models defines mapping between threads and controls scheduling behavior. Three main models exist, that is nothing but which we'll discuss the later. Defines mapping between threads. A thread is a lightweight process. This is also the process. It's a lightweight process. The lightweight process which is presented inside of the process is mapping between the thing and controls scheduling behavior. Many to one model means many user threads, one kernel thread, simple and fast. Blocking affects all threads. This is many to one model. And one to one means each user threads can connected with one's kernel thread. It's high concurrency, higher overhead. This is the one to one model. And many to many model is many user threads, many kernel threads is connected with the many kernel threads and flexible and scalable complex implementation. This is the many to many model. Threading issues is problems in multi-threaded programs and affect correctness. If one thread executed means that result cannot be updated in the main process means that can be affected the entire process correctness and needs careful handling. This is the threading issues. And fork and executes means fork it duplicates process, thread duplications decision need, and exec replaces process image. Parent its need to fork means it's created the subprocess which is nothing but thread, and the thread can be executed as a child process. If it need any other IO devices, it should comes under the wait state. And this is signal handling. Signals sent to process or thread handles by specific threads. So OS is completely dependent. Thread cancellation. Terminate thread before completion. This is thread cancellation. The thread cannot be completed. Before that, it have to be terminated by the CPU. So, and the second point is asynchronous cancellation, and the third one is deferred cancellation. These are all the cancellations things which has happened in the thread. This is thread pools. Pre-created threads reduce creation overhead, improve performance. If your process needs to split it as a 4 threads, which have to be created very early and reduce creation overhead. If we want, if the process can only split it 4 threads means it's enough to create 4 threads. Its overhead above 4 thread is if we split the threads process into above 5, above 4 or equal above 4, that is overhead. So it's and improve performance. Thread specific data. Threads for private data for each thread and avoid conflicts and ensures correctness. This is the thread specific data. And real world applications means web servers, concurrent systems, database applications. These are all the real world applications. There is a two space in each OS, which is user address space and kernel space. Let's summarize the session, which is we discussed about threading models, which is one to many, many to many, and one to one. These are all the models. Each has advantages and limits, and threading issue must be managed. Thank you.